All right, yesterday you learned how to graph using a table of values and using slope-intercept form. Today we're going to be learning about how to graph using intercepts, specifically the x and the y intercept. Now, when two things intercept, that means that they go through each other, right? If you think of an interception in football, right? It's where the football from the one team gets intercepted by the other, right? So there's a crossover there. The same thing is true of a graph. So if you take a look at the graph that is shown, there are two intercepts here, right? There's one on the x-axis and there's one on the y-axis. Now, if you were to write the ordered pair of the intercept on the x-axis, notice that that would be 4, 0, right? And the intercept on the y-axis is the ordered pair 0, 6. Now, the one thing that's going to be true of every single x-intercept, or of every single point that's on an x-axis, would be that the y is 0. So therefore, to find the x-intercept, you set y equal to 0, and you would solve for x. Now, if you take a look at your y-intercept, right, that's on the y-axis, every point on the y-axis has a 0 for the x. So to find the y-intercept, you let x equal 0, and then you solve for y. Now, the nice part of these is that if the equation is in what we call standard form, it is really easy to graph using the x and the y-intercepts. So if you take a look at the example in the little yellow box here, it asks to graph the line of 3x plus 2y equals 12. That equation of 3x plus 2y equals 12 is in standard form. Now, the standard form of an equation of a line is ax plus by equals c. Now, the nice part of this is if you are trying to find your x and y intercepts, all you really need to do is cover up the one variable because it is zeroing out and solve for the other. So, for example, let me write this off on the side, right? We have 3x plus 2y equals 12. If you go to get the x-intercept, right, the x-intercept means we need the x left. So you would be getting rid of the y, right? And now you have 3x equals 12 left. So x is 4, and your x-intercept is 4, 0. Now, again, starting with that same equation of 3x plus 2y equals 12, if you're looking for the y-intercept, get rid of your x, because that would be zeroed out. And your equation is 2y equals 12, so y is 6, thus giving you your y-intercept at 0, 6. So when something's in standard form, it's actually really easy to graph because all you need to do is find the 2 points, your x and your y-intercept, and you're good to go. All right, let's take a look at a few examples. So copy this one in your spiral. The first one is we have 5x minus 10y equals negative 12. So 5x minus 10y equals negative 12. If we go to get the x-intercept, you're going to get rid of the y. The reason you're getting rid of it is you'd be technically putting 0 in for y. So negative 10 times 0 is 0. It's gone anyway. That leaves you with 5x equals negative 25. If you were to divide by 5, x is negative 5. So your x-intercept is negative 5, 0. Now you'll do the same thing for your y-intercept, only in this case, you need the y left over, so you will zero out the x. So that term is going away. You have negative 10y equals negative 25. And in this case, when you divide, you end up with a fraction or a decimal. So this will give you 2.5 or 2.5. So your y-intercept is 0 and then 2.5. All right. Now, when we go to plot our x-intercept at negative 5, you're going 5 to the left from the origin. So 1, 2, 3, 4, 5. Your y-intercept is 2.5. And you will connect the two dots. Now, remember, a lot of times students will actually give me this. That's a segment, not a line. In order to have a line, you've got to make sure that you put arrows on both sides. All right, let's go over to example 2. In example 2, we have 9x equals 3y plus 6. Now, you might notice that this is not yet in standard form, and that's okay. You can actually leave it like this. So 9x equals 3y plus 6. In order to get the x-intercept, you're going to zero out the y. That leaves you with the equation of 9x equals 6. And when you divide by 9, you get 6/9, which is the same thing as 2/3. So your x-intercept is 2/3 and 0. All right, going to get your y-intercept, you need to zero out the x because you have to have the y left. Now notice when you zeroed out the x, that left nothing on the left-hand side. So you now have 0 equals 3y plus 6, which is a two-step equation to solve. So the first thing we would do is subtract the 6. And then if we divide, we get y to be -2. So that intercept is 0, -2. All right, so we're going to plot 0, -2 on the y-axis. And then 2/3 0 is just before the 1. And we will draw our line and draw our little arrows. And our graph is completed. All right, let's move to example 3. In example 3, we are again getting our x and our y intercepts. Again, in this case, it is not in standard form. So we'll start with what we have. The first thing, if we get the x-intercept, we're going to zero out the y. So that leaves you with 36 minus 4x equals 0. Again, this is a two-step equation. So if you subtract 36, you get -4x equals -36. And then when you divide, x is 9. So that's 9, 0. I'm going to recopy that equation in order to get our y-intercept. To get the y-intercept, you need the y left, so you zero out the x. That leaves you with 9y plus 36 equals 0. Again, another two-step equation. So if you subtract your 36, you have 9y equals -36. Divide by the 9, and y is -4. So our y-intercept is 0, -4. Now we'll go ahead and plot that. 1, 2, 3, 4 down. Now if you notice, we don't have 9 spots on our x-axis. So you can always change the scale of the x-axis if you would like. So for example, I'm going to go by 2s. But in order to let others know that I'm going by 2, I'm just going to label the first one as 2. And that way it kind of signals to the teacher that you're using a different scale on that x-axis. So 2, 4, 6, 8, and then 9 would be between the 8 and the 10. Now, you could have also just added an extra tick mark off on the side, and that would have been fine too. Now, the other thing I would like to point out when we take a look at the first 3 examples, notice that we wrote each of our intercepts as an ordered pair. We didn't just say x-intercept equals 9. We wrote the ordered pair of 9, 0. The reason you want to do that is because an x and a y-intercept is a point. It's not just a number. It's an actual point on the graph. So we need to make sure that we're representing it as such. All right, number 4, copy down 5x minus 2/3 y equals 10. Now you may notice you have a fraction. Again, you can choose to work with that fraction if you want. Otherwise, if you think back to when we solved equations, you might remember that it's often easiest to eliminate the fraction by clearing it. So I'm going to try to clear this out. So if you look at all of the terms, right, the common denominator is a 3. So I'm going to multiply everything through by 3 first. So that gives us 15x minus 2y equals negative 30. That now will not only eliminate the fraction, but it also keeps me from having to work with them. All right, so if we go to get the x-intercept, we're going to zero out the y. That leaves us with 15x equals negative 30. If we divide, x is negative 2. So our ordered pair is negative 2, 0. I'm going to recopy that equation of 15x minus 2y equals negative 30. And now in this case, we need our y-intercept. So to get the y-intercept, you zero out the x. That leaves you with a negative 2y equals negative 30. And when you divide by negative 2, we end up with a positive 15. So that's going to be 0 and 15. All right, if we go ahead and plot our points, we have negative 2, 0 on the x-axis. Now, clearly, we don't have 15 tick marks going up, right, on our y-axis. So again, I'm just going to label the first one as 5. I'm going to go by 5s. So 5, 10, 15. And I'm going to draw our line in. Yeah, my line kind of was a little crooked, but that's okay. All right, I'd like you to take a minute and try number 5. Number 5 is very similar to number 4. It has a fraction. Again, you can either choose to work with it, or if you're like me and you don't like fractions, you can go ahead and get rid of that fraction by multiplying through by a common denominator. If you chose to clear the fractions, you would have multiplied through by 4, giving you 4 minus y equals 8x. And then getting your x-intercept, you would zero out your y. That would leave you with 4 equals 8x. And when you divide by 8, x is 1/2. Then getting that y-intercept, you would zero out the x. That would leave you with the equation of 4 minus y equals 0, which if you subtract the 4, you get a negative y equals a negative 4. So y is positive 4. So your y-intercept there would be 0, 4. Now, if you chose to work with the fractions, that's perfectly fine, and you should have actually gotten the same thing. So you would get the x-intercept to be a half, y-intercept to be 0, 4, 1, 2, 3, 4. You plot your points, draw your line, and you have a nice graph. All right. Take a moment. Please try number 6. Number 6 is not in standard form, but there's really nothing too fancy about it. There's no fractions or no decimals. So if you are getting the x-intercept, you would zero your y. That would leave you with 0 equals 4x plus 12, which is a two-step equation. And when you subtract the 12 and divide by 4, you get the x-intercept to be negative 3. Starting with rewriting that equation again, when we go to solve for the y-intercept, you now zero out the x. That now leaves you with 3y equals 12, so y is 4. So in this case, we get some nice straightforward intercepts. Go ahead and plot them. So negative 3, 0 is on our x-axis, 0, 4 is on our y, and then you have your graph created. All right, number 7. Now, if you look at number 7, this one's a little bit different. You should recognize that not only do you have an x and a y, but you have two x's. So sometimes in a situation like this, it's always easiest to sort of combine like terms before you go ahead and you solve for those intercepts. Now, if you think back to what we talked about with standard form for an equation of a line is when your x and your y are on the same side of the equation. It ends up making each intercept, when you go to solve, a one-step process if the x and the y are on the same side. So in this case, I'm going to first start by subtracting 3x from both sides so that x and y are both on the left-hand side. So that will give us 3y minus 4x equals 12. All right, now to get the x-intercept, you zero out your y. So now we have negative 4x equals 12, and when you divide, x is negative 3. So that intercept is negative 3, 0. And then if we copy our standard equation again of the 3y minus 4x equals 12, if we want our y-intercept, you'll now zero out the x. That leaves you with 3y equals 12, so therefore y is 4. And we could go ahead and plot our points on our x and our y axis and draw your line, and then you are finished. All right, if we move to example 8, let's copy it down. You have 3 minus y equals 2. Now, very often students will say, wait a second, you're missing something. You're missing the x. I'm actually not missing the x. So this is one of our special cases when we only have one variable, and that will tell us that we will either have a horizontal or a vertical line. Now, if you think about this, there's only one intercept in this case to solve for. The only thing you could possibly solve for is y. So when we solve for y, if we subtract the 3, you get negative y equals negative 1, so that means y is 1. That means also that we only have one intercept. We only have the y-intercept. There was no x, which is a 0, and the y value is 1. Oops. So if we were to plot that, and we know we only have one there, we also want to think about what this equation of y equals 1 means. That means that no matter what point is on our graph, the y is always a 1. So if you were to look at your graph and try to find another point in which the y is 1, well, what if we had 2, 1, right? That has y as 1. What if we had negative 3, 1? 1, 2, 3, 1, right? Those all fit that condition where y is 1. So in this case, you end up with a horizontal line. You will always have a horizontal line if your equation ends up just being y equals a single number. And it is a vertical line if you end up with x equals a single number. All right, now we're going to take a look at a little word problem here to try to see if we can put x and y intercepts in the context of a problem, a real world problem. So in this case, Adrienne is a hairstylist at a new age salon. She pays a monthly fee to rent a station at the salon. The graph below shows the profit she makes each month based on the number of haircuts she performs. So let's take a look at the questions. And let's first, before we even look at the questions, kind of just take a look at our graph, right? There's some important information. X is talking about the number of haircuts, and Y is talking about her profit. Now, in question 9, it asks us to determine her profit if she did 21 haircuts. So if Adrienne does 21 haircuts, what's her profit? Well, if we go to 21 and we go up, we see that we have a point here, right? And that point is 21 when the profit is 150, right? So when we have 21 haircuts, if we kind of travel over here, right? Profit is $150. Now it asks for the x-intercept. Well, looking at the graph, we can determine that. We want to find what is the point at which this graph intersects the x-axis. Well, our number of haircuts is the x-axis, and this intersects at 12. So the x-intercept is 12, 0. Now, we want to think about what do those values represent in the context of the problem. Well, when we see 12, that is x. X refers to the number of haircuts. So that means Adrian cuts 12 haircuts when there is $0 in profit. So that's basically what you would call your break-even point, right? Now, what is the y-intercept? According to the graph, if we look, y is our profit, right? So our y-intercept is down at negative 200. So that's 0, negative 200. And they want to know, what do these values represent in the context of the problem? Well, if we look at the x, always start with your x, right? When Adrian when she does 0 haircuts, well, let's talk about this a second. Let's stop here, right? If she has a negative $200 profit, we need to think about what that is representing. That means that she has a loss, right? Not a gain. So we would say when she does 0 haircuts, she has a loss of $200. Now, in the real world, we want to think about, what does that represent? Right? What is this loss of $200 if she's not cutting anyone's hair representing? Well, if we go back and look at the problem, right, it says she's a hairstylist, and it says she pays a monthly fee to rent the station. So if she's not cutting any hair and she has a loss of $200, then we would be able to surmise that the $200 is actually her monthly fee for renting that station. So you're very often going to see, especially in business, you can relate profit and loss on linear graphs like this all of the time. And you're able to actually decipher the values right from the graph given the context of your problem. All right, we are done with today's notes. We ask that you log into Google Classroom, do the assignments by 11 a.m., and we will meet with you at 11:30 a.m. to go over those and to wrap up the day. Have a good one. See